Question 15. Prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. Okay, I begin all these questions the same way. On the write down n for any integer, 2n is all my even numbers, and 2n plus 1 must be all my odd numbers. They're even because it's in the 2 times tables, and this is 1 bigger than the 2 times tables, must be an odd number. So I'll begin with that. Now you're going to choose one of these. So I'm going to choose one of them, and we're going to see if I can figure this one out. Okay, so I look up into the question, and it asks me for of any two consecutive integers. Any two consecutive integers. That is telling me that it's just this one we're dealing with. So an integer is n, a consecutive one is the next one, and that will be n plus 1. Between the squares, okay, so I'm going to square them. That's going to be n squared and n plus 1 squared. I'm going to multiply this bracket out. That's going to give me n squared plus 1n plus 1n plus 1. That's if I follow my arrows. That's going to give me n squared plus 2n plus 1. Ask me for the difference. So I'm going to put my answer down here. The difference is going to be the largest one. Subtract the smallest one. Now if I do that, n squared take away n squared is going to leave me with this. It's going to leave me with 2n plus 1. You're asked to prove that that was an odd number, and the proof is, that's the proof basically, because that is an even number. And if I add 1 to an even number, I'm going to get an odd number. So that is the definition there of an odd number. We see that here. I'll put it here at the very start.